In class today, we covered the 3 steps to solving inequalities. If you weren't here or you just wanted a refresher, here you go. So the first step is we need to use organized algebra steps to isolate our variable. And I'm serious about that, like organized steps. I want you to show every single step you do. I want you to line up your inequality symbol as you work, meaning that as you work, that inequality symbol stays right underneath the original. And I want you to rewrite your new simplified equation with every step you make. So here's an example of what I mean by that. I'm going to solve 2x minus 7 is less than or equal to 11. I'm going to start with isolating that variable by making a 0 with that 7. So I'm going to add 7 to each side. So that's what I showed that step, adding 7 to each side. Now I'm going to rewrite my new simplified equation. So I have 2x is less than or equal to 18. I'm going to show my next step, which I then need to divide by 2, multiplicative inverse. Let's get that down to 1x. And then last x is less than or equal to 9. Okay, this next step is graphing. So I'm actually going to circle that because that's my solution. I saw a lot of different things going on with the graph. Your graph needs to have at least 3 pieces of data on your scale. Meaning, like I saw some people just be like, well, here's 9, and then x is all of these things. That's not enough information. We want to be, if you want to start with 9, cool. I want to put 10 on there. I want to put 8 on there. There's 3 pieces of information. So I saw some people also just like kind of go like that and like circle the region where the solutions are. That is not graphing solutions. In order to graph a solution, we need an open or closed dot at our boundary point. So our boundary point is that point where the solution becomes true or untrue. So in this case, that's 9. That's our boundary point. O-U-N-D-A-R-Y. Boundary point. Okay, we need a closed dot because in our solution we have x is less than or equal to 9. So we're going to put a closed dot there. There's our boundary point. And then you need a line with an arrow pointing to all of your solution sets. The reason you need an arrow is if I just kind of go like that, my graph shows that my solutions are 9 and everything between 9 and 8, and then maybe a little bit beyond 8. But if I add an arrow on there, that arrow means that those solutions go on and on and on into infinity. There are an infinite number of solutions to this inequality. And now we need to check. And by our checking, we need to go back to our original inequality and replace the variable with a solution from our solution set other than the boundary point. So it's really important that you don't replace x with that boundary point. You want to replace it with something other than the boundary point. We could replace it with 8. Why not? 8's right there. That's a part of our solution. So I'm going to say 2 times 8 minus 7 should be less than or equal to 11. Right? 2 times 8 is 16. 16 minus 7 should be less than or equal to 11. And indeed, 9 is less than or equal to 11. That means we did it right. If we'd come up with an untrue statement, that would mean we need to go back to our equation and find and fix our error. You can't just be like, whoops, it's wrong, and then leave it. You have to go back, find and fix your error.